Okay, so welcome to the channel. Welcome to the CompTIA two core exams. That's the 220-1102. This is the CompTIA exams, and we're in page or slide 165. So on the channel, you have two videos already. You have the series 1 and series 2. So this is series 1. It covers
Okay, welcome to the
covers I think up to
from
105.
NS.
This is series 1. Then you also have series 2 that covers up till 165. Okay, so I'm going to write on the third series. It's going to write on from 165. So see how far we can go today. Okay, so Internet of Things. So I think I introduced Internet of Things in the last class, where I talked about anytime you hear the word Internet of Things, you're trying to say, I want to be able to manage. I want to be able to control. I want to be able to use. I want to be able to send data, receive data through devices over the internet, right? So it can be your car, it can be your AC, it can be your window, it can be your door, it can be anything. It can be your gate. You want a solution whereby you can send signals. CCTV is a classical example of IoT, right? It's a thing, it's a device, it's a gadget. How can over the internet I'm able to see what's happening in my house? How can I be able to open my door even while I'm not there? And the only way that can be possible is if it is in a network. And aside your home network, you want that your home network to be on the internet, then you want your own mobile phone to be on the internet. So once those two are connected together, then you have Internet of Things. So you have its application in thermostats, in light watches, okay, I didn't wear my watch today. With the watch, you could connect it with what was it called? Connect it with a tablet or a phone. You can monitor your stuff. Even in some watches, you could actually connect it to an app, and somebody elsewhere can actually see what is happening to your bit rate and your heartbeat and all of that. So these are the applications of Internet of Things. Look at this fridge now. So this fridge, you can actually, with a mobile app or the web, you can switch on the fridge and know how many volts it's consuming, how much kilowatt of energy it's consuming. Then, of course, I don't know what this is going to be, maybe how much power it's saving and the rest. So it has a timer. You can switch it on, you can switch it off. Even when you are not physically there, when you are far away over a network, that's why it's called internet, right? Over a network, you can actually control it. So today we're supposed to start from how do we set up a SOHO. So SOHO is a small office home network. So this is small, this is office, both of this is home network. So it can be wired, it can be wireless. So if you're doing cybersecurity, if you're doing cloud computing, you want to get to know, do advanced stuff in tech, then you need to understand that most of those things are based out of a SOHO network or maybe an enterprise network. But at this level, we just want to know what's the SOHO network and what is it built with. How can we set up one? So before the GUI interface in Windows used to be slightly different. When we got 2000, it's slightly different. When we got XP, when we got Vista, when we got Windows 7, when we got Windows 8, when we got Windows 10, when we got Windows 11, all of these things have changed over time. I can still remember when you need to set up a network, you have to run the process on, let's say, Windows 2000. You have to run the process on the first system, run it on the second system, run it on the third system, run it on the fourth system, run it on each of those systems. Then somehow they are now synced together and you can have the network. But these days on Windows 10, Windows 11, all you just need to do is to plug in your cables or connect each of these wireless to a device, and you go to your network and set in permission, right? Your network configuration and set up permissions. Once you set up permissions, all of these guys will be able to connect. But just understand that, okay. Network sharing center. So this interface is like the interface that you had in Windows 7, Vista, 10, 11, 8, 10, and this 11. Windows have not changed this exact interface as you see it. It was slightly different in Windows XP. But from Windows 7, this same interface is what you see. All you just need to do is that if you are connected, you just go to your advanced sharing center and you tap turn on all the discovery that you need to turn up. Once you turn on this discovery, turn on what you want to turn on. If it is on, it then means that if I drop a file within the system on the network, it will ask me for the password of this system. If I don't put it, I cannot share. So let's look at some of the principles in Soho networks. Install, configure wired, wireless, small office home networks. IP addressing. So what you need to understand is that if you need to have a network for a wireless network, DHCP comes in, right? So IP addressing is very important. Then we need to understand what are the different types of IPs, what are their bits, what do they stand for, what are the advantages, what might be like their likely disadvantages. So IP addressing, we were saying, how do we identify each computer? How do we identify each tablet? Typically, any gadget, if you use an IP camera, then you need to give the camera an IP address. If you use a wireless or what's it called? A TV that is a smart TV, it will pick an IP address from the router. If you use a telephone, it's going to pick up an IP address. So an IP address is just like an identifier. So different ways we can identify a system or we can identify a gadget. We can use the IP address. We can use the MAC address. We can use the loopback address. We can use what again? So these are the ways we can use to identify. And we have two major types. So they are assigned to devices for communicating outside their local network. We have IP version 4 and we have IP version 6. Right? So let me get Chat GPT here. Now, we have IP version 4. Things you need to understand is that it was the first type of IP address we had. Then it is divided into two sections, this section and this section, right? So this is the network portion, and this is the actual IP for or number for that particular system. I think in the last class, when I did IP config all, I explained that this is going to be my gateway, my default gateway, and this is my IP address. If you watch very well, 192.168.1 is unique, and also 192.168.1 is unique. So this is the gateway, this is like the router, and of course, this is the system, this particular system IP address. Yeah. If I connect to another PC, it's going to, the router DHCP dynamic host configuration protocol is going to assign an IP address to that other system. If you put in another telephone line, it's going to assign. If I connect my smart TV and check the IP address on the smart TV, it's going to tell you, it's going to give it another number. If you connect the camera, it's going to give it another number. If you connect another laptop, it's going to give you another number. If you connect another PC, it's going to give you another number. So you have different classes. We'll talk about that. So let's just do a summary. Let's say IP version, two major types of IP address. Their differences, their advantages, and application. let's have this in a tabular format. So we know we have two major types of IP address, version 4 and version 6. You should understand how it is being notated. Then you should understand how much address can it take. One of the reasons why we have version 6 is because version 4 could only do 4.3 billion. And of course, what population? Okay, let me see. World telephone in circulation, right?
Yeah.
World phone usage in circulation. You see, I'm saying 6.4 billion. Or maybe this is a forecast. Yeah. Okay, in 2022, this is 6.4 billion. So if each of these phones, or let's say 60% of these phones are smartphones, it then means, of course, by 2023, it then means that this is going to be exhausted. This is aside laptops. This is aside printers. This is aside cameras. This is aside IoT devices. So you see that if we're going to assign IP address to each of these guys, it's never going to be possible. So we need to have version 6. This has 340 on the decillion. This should be around in the neighborhood of 12 zeros. How many zeros? 36. So it's
that's 340 trillion.
Okay. 340 trillion address. You know, trillion is 9. Trillion is 9. So yeah. the amount of IP address you can be able to have with version 6 is quite huge. So even if we have 20 billion population, it is still be able to cater for it. Of course, with all the tablets, the printers, the cameras, all of those IoT devices. Now, the difference, of course, NAT's configuration, often manually configured. This can actually pick its own address. NAT dependency. Now, you need to understand what NAT is. So NAT is network address translation. I think I've explained this before now. I've said that this IP address is my gateway IP address, is the IP address, my mast, the tower I collect my network from. It's assigned this to my router. My router now assigned this to me, right? But the point is, what is my IP address? What's the IP address of the router I am connected to? Sorry, of the mast I am connected to. So it is 105.112.115.254. So this is the one I am connected to. And if I do a quiz, I'll be able to tell, okay, who owns this IP address? So this is from the mast. So everybody around this vicinity that's going to be connected to this mast is going to bear this particular IP address. So that is what my router is speaking from. So this is Airtel Nigeria. And I can confirm it by checking this. So it's all correct. So my router is 192.168.8.1. The mast is giving my router 105.111.115.254. The router is giving me 192.168.1.120. So it goes like this. So you have local IP address, then public IP address. So the public is the one the mast has. My local address is the one that the router is giving me. Right? Now,
and then your device now has its own.
Of course, every device that's going to be connected to this router is going to have its own. Now, the question is, what is NAT? NAT is network address translation. So NAT translates our local IP address into the public IP address. So once there's communication, so it can identify what is my, if you do CCNA3, that is enterprise networking, security and automation, this is broken down into much detail because it's a module on its own. Now, but for here, you just need to understand that you have your local IP, you have your public IP. So NAT helps to translate, to convert what you have here locally to the outside world. And when information comes in, it translates it back down to your local network. You don't need any of the IP address here locally outside. Nobody needs it. It's just meant for communication between everybody within this network. What the outside world is going to see is the one of the mast, not a local IP address, right? Because it's just meant for your internal communication. So you said that IP version 4 is what's it called? It's a common due to scarcity, of course, but this is less reliant on NAT because you could get this directly, right? There's no translation that needs to be done because this IP address are sufficient enough. So the idea is that if you have 20 systems connected to my router, they're all going to bear their own local address. They will have only one public address. That's the one of the router, right? So it helps to maximize IP address. So with that one from the router, everybody can share that one. But with IP version 6, we don't need to share. Each and everybody can have, so it's less reliant on that. There's no need of translation. The security, of course, is less secure due to NAT, but this one you have improved security. Then simpler header structure. Header structure has to do with the message, like the metadata, the data that describes the data. So it's simpler. This is more structured. This has more structure and, of course, more information. Then QoS is quality of service support. So this has limited, this has improved. Migration difficulty, challenging due to scale, right? Easier migration due to size. So here we have limits because of the number of IP version 4 address that we can have generally. That's why you're going to see most routers now are going to give you both IP version 4 and IP version 6. This is 4. And this is, this is 6. And this is 4. Right? 6, 4.
So they give both IP addresses same time.
Yes. For the past so many years now, most routers will assign you both, right? So whichever what you're doing is compliant on, you can be able to use any of them. The idea is that with time, we'll phase out use of IP version 4. But of course, it's going to stay for a very long time. Okay, so these are some of the difference between, you see, usage, older devices and networks, then modern device and network, existing network, legacy. This is future proofing. So it's meant for the future. So these are some of the things you need to know about IP version 4, IP version 6. And you understand that this is 32-bit, this is 128-bit. This is how it is written in decimal, whereas this is hexadecimal. And when you hear hexadecimal, you mean you're going to be having 0s to 9, and you're also going to be having A to F. That's why you're going to see FE 9, 1. You're never going to have G because it's hexadecimal, right? Hexadecimal. So you're going to have 0, 1, 2, 3, 4 up to 9. Then you're going to have A, B, C, D up to F. Is that fine? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You're going to have combination of this. So you could read more, research more on the differences, the advantages. This one helps us to like meet more IP demands. This one is what we started with. Then this one has limits. This one is very huge. And of course, all of that. So this is the network portion. This is the host portion. That's why this guy is always 1. Then of course, this is the subnet max. Now, a subnet max is used to define subnetworks, but this is beyond the scope of A+ exam. If you are doing CCNA 2 or CCNA 3, that is enterprise networking, then you bother about octets And if you also watch I think I have a video on the channel or on CCNA1. If you want to still study more about that, you can check the playlist on. You can check the playlist on CCNA1. I think I addressed some of those things. CCNA1. So you have number systems, right? Number systems, how they are addressed, subnet marks, calculating all of those stuffs.
Okay, good morning. Hi.
Right? So binary to decimal and all of that. So how do you come about? Why is it 192.168.11.10? How do you come about? What's the conversion? Remember what we did in I think maybe secondary school or high school mathematics, base 1, base 2, base 3, all of those stuff. The idea is that computers don't communicate in decimals, right? They communicate in binaries. So all of the zeros and ones, right?
Yeah.
You and I, you can't tell me that, Mr. James, what is your IP address? You can't tell me that, okay, Mr. Victor, my IP address is 11000000.1010101000.000. That's like computers, right? Binary.
Yeah.
But you need to take that back to decimal that I can comprehend, right? So you tell me 192, you want to take it to like base 10. So you tell me 192.168.11.10. So it makes sense to me. Because if I say 1, this is 1, 2, 3, 4, 5, 6. 1, 1. Don't forget, this is 192. 6 zeros. 1, 1, 1, 2, 3, 4, 5, 6. 2 base 10. So it's going to give me my answer as 192. Are you there?
Binary.
Yeah, so binary to base 10. So this is base 10. So you and I, we understand base 10.
Yeah.
Right. So their communication is going to be in binary, but we are going to understand this as base 10. So, but it's beyond, so that is beyond the scope of A+. You just need to understand how networking works, how the IP address are assigned. Right? I've explained public and private IP address. The private is the one you have within, given by the local area network. And the public is the one that is going to be discovered by anybody on the internet. That's the one that your must assign to the router. NAT, I've explained NAT. How do we modify the IP address as information across the different routers? So it's NAT that does that translation. It will translate it from this through to this on the LAN, then sends it to the what's it called? The mask. The mask now is able to send it through the ISP over the internet. I've already explained version 6, IP version 6. Understand that IP version 6 can do 340 on the zillion addresses. Then IP version 4 can do 4 billion addresses. So if you see a question that has to do with if we need to have a scaled network where we don't want the security issues or the limitations of NAT, what is going to be our solution? Of course, it's going to be IP version 6 address. So understand that IP version 6 is also 1 to 8 bits. IP version 4 is what? 28 bits. Sorry, 32 bits. 32 bits, 128 bits.
128.
So these are the things I just explained earlier on, the different types, global unicasts. Then you have link local address. Then, of course, you have site local address. Then, of course, you have some address we call special address. I normally classify them as loopback address. So it's like the address of the local system, even when you are not connected to any server, any router, anything. People that do mobile app development, that set up applications physically, locally, if you are configuring your XAMPP or configuring your IIS or configuring your either your Linux or your Windows server on your system, you hear things like loopback address. So it's like the address of the system, even if it's not specified, because normally you cannot have an address without being assigned, right? Let's ask ChatGPT what is a loopback address. What is a loopback address and what are the usage? So it's a special IP address used in networking to test the network interface or communication within the same device without actually sending data out of the network. It is referred to as the local host, right? That is the address of the system itself. The loopback address allows the computer to communicate with itself. You know, when you are developing, when you are setting up something that is not going to go out, then you need to like communicate with yourself, like a developer that is building something or a network engineer that's trying to test something within the system itself. So that loopback address is like its own address to like ping and see whether the guy is alive, the guy is open, the guy is working, right? So most of the times is 127.0.0.1. So the IP version 4 version is what? .1. The question is that how do we come about .1? So it's what they call compression of IP address. So once you have leading zeros, it becomes 0, 0, it becomes ... and you reserve the 1. That's why you're going to see IP version 4 address are going to have some of these dots. Some of these dots are zeros. If you have it in multiples, it's going to have it ... Like here now, you have a lot of zeros. That's why you have ... like this colon, right? I think if you check my video on CCNA, it can give you better understanding. Usage, network testing, software development, I just mentioned that. Programmers can use the loopback address to test the functionality of the application locally without trying to host it on AWS, on hosting, on whatever. So they can use it to do testing. Local web development. Web developers often use loopback address to host and test websites locally. Database testing. Awesome. I love the fact that it has really pointed out most of these things. Then, of course, you have compatibility address. I haven't used this. I'm always used to the special address, site local link, global unicast. I think those 3. Right? So these are some of the ways that IP addresses can be applied. And don't forget, an IP address is just to identify something. Right? Yeah. That's why we have IP address. So how do you know your IP address? You run ipconfig. We've been doing this, I think, since the last class. You go to your CMD, clear screen CLS, and you say ipconfig. You're going to see your IP address, your gateway, and your personal IP address. Then if you say ipconfig-all, it's going to give you a robust details of all of the routers you have, or rather all the adapters you have on your system. For Linux-based systems, if you run either Kali Linux, any Linux variant, Mac is also a Linux variant. Mac OS Linux variant. Okay, not linked together with my previous question. I'm just asking what Linux variant. Okay, it even answered, but it's like got confused. It gave me same reply and I added this here. So both Macs and Linux variants such as Ubuntu, Settle, Debian follow the same fundamental networking principle. Linux variant is Mac OS. Okay, Unix, sorry to say, not Linux, Unix, right? And okay. So Mac is based on Linux. Sorry, Mac is based on Unix, and it has similarities with Linux, right? So just for clarification. Okay, so if you're on Mac, so you run ifconfig. If you're on Windows, you run ipconfig. So these two concepts are very important, static and dynamic. I've explained this in previous section. Anytime a router is to assign an IP address to a system, two ways it can do that. It's going to do that dynamically or static. If it's dynamically, then it's going to be using dynamic host configuration protocol. If it's static, that means the administrator will have to assign it. So it's something like this. Oh, let me see. I think I have network adapters. Network. Properties. No, no, network adapters. Change adapter settings. Yeah, so I come here, I say properties. I said I want the version 4 address, properties. So I assign. This is going to be manual. If I change this now, we are going to be off this call. But right now, it's on automatic. So you get your adapter, list of adapters, go to your network area. Say you want to see your go to your network and sharing center, maybe depending on your version of Windows, change adapter settings. You are in the list of your adapter. Go to properties. This. If I tap here now, it's going to ask me, put in the IP address. So what if I do that, I'm doing a manual IP assignment. Right now, it's using DHCP, right? So those are the two ways IP address can be assigned. For some critical assets or critical items on your network, you might want to use static so that it doesn't change. Because what happens is that if I leave this network, now, this was assigned to me on Monday, right? 7th. It's going to expire tomorrow. If I don't come back after tomorrow to this router I'm using now, and I stay for 2 weeks, somebody else might be assigned 120.
Okay.
So, but if I do static assignment of this 192.168.1.120, the router will make sure that nobody uses that 120. It's going to be reserved. So if I have...
If you use it...
Come again.
I said, if you use it till tomorrow into this 1605, and you're still using it, it won't assign it to another. But if you don't use it after this 1605, yes, which is 5 after 4.
Yes, there's high probability that it's going to assign this particular number to somebody else. And if I come back, I'm going to see something notification here, IP conflict. So all I need to do is to go off the network, come back again, and it's going to reassign a new IP address to me. But if I assign this guy statically, it then means that maybe there's a device or something that is always communicating with this guy, and I don't want that IP address to always be changing. Those are some of the applications, reasons why I want to use a static IP address. Reasons why assigning static IP address is awesome. Stability, right? predictability, network services for like printers, for some certain things that you want to always make sure that, or remote, somebody's going to access something from somewhere. You want to make sure that that IP address does not change. Then you want to use static IP address. Then you also use for network monitoring. If you need to monitor something, you don't want the IP address to be changing, right? If you're going to be doing port forwarding, if you need to perform some kind of access control, that is ACLs, it then means that we might have system A, B, C, D. They cannot access also IP address. System D, E, F, G. They cannot browse the internet. System this. So it then means that the one way you can do that is to first give them IP address. So you cannot say, okay, so IP address cannot. So you can use software's network monitoring tools to be able to do that. So if you want to implement policies, then you need to have static IP address. You cannot just allow people to come pick up IP address and they use. So you can identify, you can control. DNS management, same thing. You buy a website, you find out that most of the times a website does not have its own IP address. It's shared. So if you want to have an identity for that particular website or for that DNS, then you give it its own IP address. Remote access, DHCP load reduction. Yes, so that the DHCP server is not always trying to assign IP address. Imagine when you have like 100 items, printers, printers, tablets, mobile phone, laptops. So people are going to be going off and on or whatever. So the server is always going to be, or the router in charge is always going to be trying to assign IP address.
Yeah.
Are you there? So to avoid conflict, I just mentioned to you that if I am going to leave this system and come back after tomorrow, it's going to tell me, brother, or let's say after 5 days, after 2 weeks, and paraventure somebody is using this IP address, it's going to tell me that, please, IP conflict. So I have to reset my router or reset the easiest part is just to reset my adapter or go off the network and come in. Is that going to assign me a new IP address? Because while I'm coming, I'm going to be coming with the old one in memory. But if it will not check and say, no, please, somebody else has that IP address, right? Because without the IP address, you will not be able to move. Okay, let me also ask this guy.
Yes.
Dynamic IP address. So dynamic address, aside for ease, right? No big deal. Just for the ease. Efficient, simplified configuration, reduce administration overhead. So you don't need a network, what's it called? Okay, so dynamic, so flexibility, IP conflict prevention, scalability, temporary connections, centralized management, configuration changes, remote management, ease of initial setup. So these are some of the, it's always ease. Are you seeing it? Ease. Somebody else comes in, want to do some things and get away. So that needs to become, let me give you IP address. So all of that. So it provides flexibility, scalability, and efficient resource management and less human interaction for network management. Are we there? Okay, so let's get back. So that's dynamic and static. Okay, so what it does and the differences. So that's what we have here. I've explained SOHO. Sorry, I've explained DHCP. So DHCP is Dynamic Host Configuration Protocol. That's that service on your router that does the assignment, right? Of the IP address.
Yeah.
This is what I just did a while ago. So how do you do manual assignments? So you go to the network settings, go to the change adapter options, click on internet IP version 4. You now come here, you now assign the IP address, right? I've explained DNS when I checked on whois. Let's say if you say Cisco now, and you check on whois, it's going to tell you the DNS server that Cisco is hosting on. That's ns1 cisco.com, ns2 cisco.com, ns3 cisco.com. If you say soutechhosting.com, it's going to tell you ns1 soutechhosting.com, ns2 soutechhosting.com. So that's domain name service. So most of the times for web servers, for web application hosting services. If you have questions, let me know, please.
No, I'm good.
So in domain name service, there are other items that you might need to be familiar with. So you have the TXT records, domain name key identifier mail. This for mails. We have sender policy framework. We have domain-based message authentication, reporting, and conformance. So DAMAC. So all of these things are things that help to tell if a domain name has credence, if a domain name is susceptible to spam. So normally in cybersecurity, when we do forensics, that's one of the things you want to be looking at, or when you are doing email forensic, or when you are doing you are trying to see the integrity of a domain name, right? If you use a tool like Talos, right? So aside getting intelligence from the website itself, let us look at one of their tools. Talos domain reputation, right? Talos intelligence. Let me say Sautech ventures.com. So what it's going to do for me is that it's going to check even my email server on that website to see the reputation. If you have always used an email for hacking, sending mails, sending all of these spam messages and whatever, it's going to tell. I see the mail server, this MX record. So those are the kind of idea.
Yes.
It does this by sending DNS mail exchange record that directs email to web mail server. So a mail server most of the times is part of a domain name service. At times it can be separate. Mail server, additional information, whois. I'm not getting so much information here. So keep it simple. Understand that these guys are what is going to help you tell if a website record is kind of how the reputation is, the integrity kind of. If you check some email reputation tools, right, and you put in an email address, it's going to give you some of those records and tell you the score and tell you the reputation of such emails, right?
Yeah.
I've explained DHCP. That's the guy that assigns the helps to assign IP address automatically. Then what is VLAN? Now, anytime you hear the word VLAN, the first word there is virtual. You already know what a LAN is. So a LAN is just interconnected computers to share resources. Resource can be anything. It can be files, it can be folders, it can be hard drive, it can be printer, it can be anything. We have a LAN. Now, when we say we want to create a virtual LAN, it then means that we can have one switch, but we want to divide that switch into sections so that we don't necessarily need to have 5 switches. Switch for admin department, switch for banking, switch for tech guys, switch for marketing. No. Let us have one switch. Let us divide it into sections, and let us call this VLAN 1, VLAN 2, VLAN 3, VLAN 4. So they will serve separate purpose. It's going to be one switch, but virtually we can see them as separate switches. What are the advantages of having a LAN, VLAN? So for improved security, for access control, for better management, and several other things. You cannot do that. And security, for instance, if you have everything in one collision domain name, you have everybody in one place, permissions are going to be all shared on that one space. But if we segment it, it then means that these people might not be able to talk to these people might not be able to talk to these people might not be able to talk to everybody, but might not be able to connect to the internet. But we just have one 48-port switch, right? So that's one application of VLAN. Can you tell me 10 reasons why VLAN is important in networking, and its advantages? Also, let's know how to implement it for a SOHO network. Let's have the reply in a tabular format. So segmentation, we can divide it. We have security. We optimize our traffic flow. Instead of this guy to just send information to everybody, he's sending something to just one person. So if it was not demarcated, he will send it to everybody. But if it's demarcated, he will send to just only the collision domain. This is what you study in CCNA 2.
Okay.
Right? VLAN tagging, DHCP configuration, VLAN security settings. Awesome. So quality of service. So these are applications of VLAN. So VLAN is very important. Any network engineer should know what VLAN and be able to implement VLAN. In the CCNA 2, you have labs that you can be able to. But for your CompTIA A+ exam, understand what VLAN is, understand its advantages, understand how you can apply it. Then for VPN is virtual private network. After COVID, most people need to access things from different places. That's a simplistic example of virtual private network, where you have to connect to something, but you're accessing it through something else, right? So most of the times your traffic is encrypted, and you have several advantages why you are going to need VPN. Let me still ask this guy. For VPN, this time just 7. How to implement it for an enterprise. Let's have the reply in a tabular format. So VLAN is secured communication between 2 points or 3 points. Can be site to site. It can be remote. And there are several reasons why we want VPN. Data privacy. You have a film house in UK that says, if you are from Asia, you cannot access our network. You cannot watch our film. Okay. I got a VPN that grants me access to that, and I am there. Right?
Yeah.
So you can bypass restrictions, geographical freedom. You see, networking is so wide. So network connection
Very wide.
Yes. Network connection types, network types, and their features. So you have wired, and you have wireless. So you have DSL, digital subscriber line. You have cable, then you have fiber. So for wired, slow here, cable fast, then fastest. For wireless, cellular, wipes, then satellite. For instance, Elon Musk, what is offering is what? Satellite. Right?
Yeah.
Elon Musk is offering satellite. He's SpaceX. It's possible that you have your Elon Musk internet. Starlink, I mean, right?
Mm-hmm.
So Starlink is what was it called? Starlink is satellite based, right? Starlink is a satellite internet, right?
Yeah.
So that's why this guy is going to be slow, medium, then of course very fast. So these are to test network speed, right? You could use fast.com. You could use other speed tests to also be able to check your network speed. So you have a question so far?
No.
Okay. So check your speed. Look at this speed now is 229. Upload is 112 MB. Download is 229. I think this should be up down also. Show more information. Okay, upload is it's even changing, it's adapting. Upload should be 6 point or whatever, then download is 16. So you should understand the generations, right? This, right?
Mm-hmm.
And how many MB per second can we have? Can you differentiate between bandwidth latency now bandwidth is how much stuff can pass through at a time, right? At what speed can that happen? Now, latency has to do with the distance. How fast can something go from point A to point B? Most of the time from the ISP to you, right?
Okay.
So we always want a latency that is low. And we want a bandwidth that is what? High.
High.
Right? But we want, don't say I want a high latency. That means you are saying I want the time, the delay between when stuff come from point A to point B to be more. No. So ISPs are going to tell you that we're going to give you good bandwidth. We have the least latency. They're trying to tell you that in microseconds, their stuff travels. You can have something that has a very good bandwidth but poor latency. That means you have good bandwidth, but things will drag.
Yes.
That's the difference between bandwidth and latency. Right?
Yeah.
While lower latency desirable, it's also important to have sufficient bandwidth for tasks that involve data-intensive transfer. So this is just ChatGPT trying to differentiate them, right? Analogy, think of a bandwidth as a highway capacity. So how much cars can you take? Then latency as the time it takes for a car to travel from one point, like I said, from one point to the other, from ISP to you. That's latency. So this is the old way. Stuffs have been done there. You can read that up. Fiber. So fiber is a copper connection. Now, if you say distance, okay, speed of fiber, it's going to trust you, right?
Yeah.
In kilometer. So 124,274 miles per second, that's fiber, right? So let's say 124,274, sorry. I want to do it in kilometer. I don't know what's your issue. 2 kilometer. Right? So this kilometer per what? Second, right?
Yeah.
Good.
That's about 200,000 kilometers.
Yes. Distance from South Africa to UK. So before you hear Jack Robinson or Jack Robinson, fiber has gone and come back. How many times? 200,000
divided by 13,005.
14 times.
Yeah.
So when an ISP tells you, I'm laying cable on the Atlantic from South Africa to UK, you're not saying, why now? Why are you laying cable from South Africa to UK? He's telling you that, yes, that once I'm done with my laying of my undersea cable, that is still going to supply me sufficient and fast speed internet. So the satellites can be in UK.
So much older telecommunications running via satellites, many people would traveling thousands of miles could just be beamed to a satellite and over to the next country. As it turns out, satellites can't handle that much flow of information. It is very expensive, and the loss of signal and data during transfer is a problem. Sending terabytes of data via space satellite could cost billions of dollars per line.
Can you hear me?
You may be surprised to know that 99% of international data is transmitted
Yeah,
at the bottom of the ocean, called submarine communications cables. The miles and miles of cables, which are roughly the size of a garden hose, carry internet traffic at the speed of light. They can carry so much traffic that fewer than 300 cable systems transport almost all internet traffic around the world. Laying and installing of cables in the oceans of our world is a fascinating business. Men and women toil long and tedious hours to make this possible. But how is this process accomplished? How are sea cables installed in the sea? Installing a submarine transmission cable is a costly and challenging activity. The lifetime of a submarine cable might be 25 years, and the technical interventions for its repairing in case of faults are also costly and difficult. In the manufacturing process, the cables move through high-speed mills the size of jet engines, wrapping the wire in a copper casing that carries electricity across the line to keep the data moving. Depending on where the cable will be located, plastic, steel, and tar are added later to help it withstand unpredictable ocean environments. When finished, the cables will end up the size of a thick garden hose. The conveyor that staff members call the cable highway carries cables directly to the port. Laying down the transmission cable on the seafloor is done by specialized vessels. They are all equipped with a turntable for at least 4,000 tons of cable and have the appropriate gear to handle it. Inside the ship, workers spool the cable into cavernous tanks. One person walks the cable swiftly in a circle, as if laying out a massive garden hose, while others lie down to hold it in place to ensure it doesn't snag or knot. Even with teams working around the clock, it takes about 4 weeks before the ship is loaded up with enough cable to hit the open sea. The complexity of laying down the cable requires a coordinated work of many specialists in different fields. Path selection is the first step, and it is done by power system engineers together with marine specialists. The survey is performed by geologists, geophysicists, and oceanographers. Once the path decided and cable is on board, starting from shore, the cable is laid out to the edge of the water. The cable laying ship gets as close to shore as possible without grounding and starts digging. Ships pull a type of plow that digs a trench and lays the cable at the same time. Sometimes, cables have to be picked up if run over another cable, or if the cable can't be buried. There is a lot of planning that goes into the route the ship will take. Undersea mountains, valleys, coral reefs, rocks, and fault lines are all taken into consideration. Preferably, the cables will also be located in areas that minimize the risk of damage from boat anchors and fishing trawlers. The special amplifiers, spaced about 25 miles apart, within these undersea cables are used usually to boost up the voltage of the signals carried in them in order to prevent the losses in the cable. However, the cable ships must take necessary measures while laying out the fiber optic cables in the seabed to ensure that they do not break and the amplifiers do not get damaged and can work for many years uninterruptedly. The typical lifespan of cables is thought to be about 25 years, but they don't really ever expire. Usually before the 25 years is up, new technology means the cables have become obsolete and new cables are run for more data capacity. When that happens, they can be repositioned and laid along a new path, which is good for areas that don't need as much capacity and want to save on costs. Since running these types of cables usually costs hundreds of millions of dollars. Some companies gain rights to pull the cables up and salvage them for the raw materials. So now you know how our undersea cables laid in the ocean. Still,
right? So
Yeah.
you see the speed. It's not here. So that's fiber for you, right? So fiber is like the super fast guy we have now, and they can travel. You see like the map of fiber cables around the world, right? They can go. People spend millions of dollars, but the value they provide is the advantage. It's an investment. You're investing millions of dollars, but you're going to get value, right, over time. Then we have satellite.
So all these cables, all these networks, they need to run cables like this.
Now, Verizon, MTN, Airtel, Bharti, all of them, there's no how. They can run to UK or run to US, then from their satellites. Right?
You know, I've always thought probably this networking thing is maybe just from satellites, maybe coverage.
No, the thing is that you have different approaches, right? And depending the kind of speed you also want. Now, what you're going to get from your ISP, you have limits to what you can get. There's a kind of speed you want, then you have to go fiber.
Okay.
So that's why if you have a router at home, even if you need some kind of speed, a router will not solve that for you. You now need a radio, a point-to-point radio, let's say Ubiquiti or any right? You now need radio to connect. Some of these connections can go from, let's say, kilometers. At times you are off area where you have internet reception. So some of them go so many miles, right? Away from where you have masts. So depending on the advantage, then you start talking about fiber and the rest. Then you have satellites. Okay. Then you have cellular. Then, of course, phone for USB data. We've talked about this.
That means most of these big blue chip companies will always opt for fiber then.
Sure.
So they are the ones that will pay for such services.
Yes, they're the ones that will pay for such. Now, let me differentiate UTP, STP. Very important. Or let's leave it to when we get to chapter 3, where we're going to be differentiating the different types of wires.
Okay.
You should know why you should go for shielded two-step pair or why you should just go for unshielded. This is going to be more expensive. This is going to have a lot of advantage compared to this, right? EMI, electromagnetic induction, radiation, noise, and all of those stuff. That's why you shield STP and versus UTP Cat6 cable, right? Right. So the shielded and unshielded, right? These unshielded, this shielded. So these have some kind of protection, some kind of shield, right? This does not have. Unshielded two-step pair, shielded two-step pair. Parameters, see the weight, this lighter, heavier. If you are crimping this one, oh my God. Your hands should be something else, right? This is also cheaper. This is costlier. This one, less prone to interference like offices and homes. Location prone to interfaces like factories and airports. So you want to use UTP here, right? You want to use STP here. Then if you don't have any prone to other items about cause interference, you want to use this because it's unshielded. So the noise, the interference is the shield around it, like the kind of material that is used to like guard the cable. That is what is the advantage, and that's why you have the difference in price. Okay, differentiate.
So that stops the interference.
Yes, differentiate UTP and STP cables. And give applications in a tabular format. Okay. Okay, look at it. Construction, protection, flexibility, cost, performance, termination, application, advantage, and of course, disadvantage. Okay. So when we get to chapter 3, we'll discuss most of these things in details. So you have LAN, you have WAN. Within a small section to share resources, 2 networks, a group of 1 or more to cover a larger geographical area. PAN, personal area network, like Bluetooth, like infrared. Then MAN, smaller version of WAN. Then STAN, storage, most of the times for files. Times they can be local, they can be cloud. If they are local, they are like the hard disks I showed you. File storage server, right? So they just share, they're just files, right? You can share them on the network. People can access them as per folders, as per disks, most of the times large space, or they can be on online, Drive, Google, pricing, right? So you pay 1 terabyte, 2 terabytes, you pay per month, you pay per whatever. Right? 2 terabytes. You pay this per month and you have it. Okay, networking tools, right? You should understand networking tools. Cutting tools, strippers, and crimpers. This is a crimping tool. right? So what you need to understand is that you have 11, you have 45. So 11 is for telephone, 45 is for Ethernet, right? So the smaller part is for what's it called? Telephone. Then the bigger part is for Ethernet. Point down tools. You can also use this to actually terminate or to cut. The patch cables connect the various parts of the patch panel to a switch and connect the RJ45 jacks to the computers. I remember when I was doing an installation, is how many years ago now? 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Like 11 years ago in a building, and I needed to have some patch panels and have some Ethernet ports, right? Because if you want a situation whereby you'll not be running cables visibly, then you have to have something that looks like sockets. I think I've shown that. You have your Ethernet port socket, something like this. So that means you pass the cable here and walk out that end. Then you can do a patch cable, just a short cable that people can plug in here and put on their system. But these days now, you have most newer systems who don't even have an Ethernet jack. True or false?
Okay, true.
So it's all going to be wireless. Right? So, but this is still, can still be used for printers, for some devices. Even printers these days have, what's it called? Wireless. A multimeter can also be used to test coaxial cables. Just last month, I got like 3 or 2 sets of multimeters. You could check DC, AC volts, but most of the time, these guys are going to be DC volts. If you want to use them, if you want to test AC volts, you have to, it's not hard to use a multimeter. So you see on the multimeter, once you're on the multimeter, you're going to see the different DC volt, DC current, then AC current, AC volt. So you need to ask yourself, what are you testing? If you're testing batteries, if you're testing power source, if you're testing battery, it's DC. So batteries, panels, USB, most of those things are DC. If you're testing power source, your UPS, your, what's it called? The point where you plug in your computers, those are AC, alternating current.
AC.
So alternating current, direct current. So one flows in one direction, one flows in both ways. One is applied for smaller systems, can also go large scale, but AC is going to be more adaptable for large scale deployment. So most of your appliances are going to be AC. Then the smaller guys and your batteries most of the times are going to be DC. Or panels are going to be DC. So you just check, put it on if it's battery you want to check, I want to check the voltage, you put it on DC. Then you put the terminals, put it on COM and positive, put it on the terminals, it's going to read out for you. Then resistance. In physics, we say it's the opposition of flow of current. So like I will normally tell my students, if you have this big wire and you have this small wire, which of these wires are going to have high resistance? They will say it's the big wire. It's not true. The big wire is going to have less resistance because it's going to not oppose electricity as much as a small wire because it's going to oppose electricity. Resistance is opposition of flow of current, right? So the bigger, the better, the more current can flow. So it's going to have less ohms. Then of course you have the Ohm's law.
Which is why the smaller cable will blow up if the current passing through it is more than what the capacity can take.
It's small. So all multimeters are going to be equipped with red and black test heads. So something like this. So if you're testing for current, if you're testing for resistance, if you're testing for volt, you just switch. Now it's on AC volt, right? So you plug it. this one, so this, the way it is now, it can only test at 1 unit. So it's this multimeter now is meant for very small devices. So if it gives you option to be able to push this guy to this place, that means it can test up to 300 volts, right?
Yeah.
So like the one I have, it could test a larger volts, right? If you swap it to the other side, you could test AC. You could test current
DC.
still about DC, right? It's a nice stuff to have at home. The toner probe. Toner probe is for your so depending on what you want to use this, most of the times you can use this for to remove papers from your printers where you have a jam, right? Tone device. Okay, know that this is for your, what's it called? Let me see. This device connects to one end of the network cable. When it's turned on, it sends a tone along the length of the cable. It's not as a inductive available can pick up a tone with the cable length. Okay. Okay, I think there's this device that especially when you walk in the roof, you can use it to know if you have a cable along that part, especially when you're laying cables above. Let me show you what it looks like. Toner probe. I think it's not the device I meant it to. Yeah, are you seeing it? Let's see. Turn dial on toner to the digital settings and set the probe to digital locate or isolate no setting. Isolate setting shows is the more sensitive setting, but either digital setting should work for receiving digital signal sent by the probe. So most of the times you need to identify to know where your cable is when you are like installing your cable over the roof. It's slightly different from a cable tester, but I won't use this device. I will typically use a cable tester. For cable testing, it's like your continuity test for normal electricity wires. So your cable tester is going to make sure that you conform to any of the code, right? So
yeah.
So instead of putting the cable into the computer to know if it is, you can get signals, you can use a tester to do all of those checks. So that's what a cable tester does. So you can check here to here, right, and see whether you have connectivity and everything is fine. If everything is not fine, then you want to cut the cable and recrimp, right? Nice enough, the guy can also test for BNC cable, the one you normally use for cameras. Then you have loop back plug connect directly to RJ45. When you use the loop back plug in the network test program, it simulates network test whether the network adapter, TCP/IP are functioning properly. Then you have Wi-Fi analyzer. Most of the time, this is going to be, it can be a hardware, it can be a software. So this is a software. The network tab, this should be a software also. Then for exam, we have okay, I think we just got into, okay, as mentioned in introduction, you have several choices for exam preparation exercises here, chapter 10. Okay, I think we just move on to all of these things as they are mentioned, the ports, PoE standards, wireless bands, channels, Bluetooth classes, wireless, IP version 5, version 6, static and dynamic addressing, NIC configuration, digital subscriber line, USB then enabling mobile spot. Just for memory purposes, some of the things you learned is protocol port, FTP, SSH, Telnet, SMTP, DNS, domain name server, and all of the rest, right? We did and looked at all of these things exhaustively. Any questions so far? Can you answer any of this?
Copy the foreign chart with the information provided. Fastest to load also. Fastest should be the fiber, right?
Ah, because we spent more than 10 minutes talking about fiber. So complete the following chart in the information provided. Wired fastest. So the idea is that here you're going to put cable, DSL, and cellular here. Then in wireless, you're going to put fiber, satellite, and wireless internet service provider. Which of the following situation requires the use of UDP but not TCP? Choose all that apply. So UDP but not TCP. So video streaming, voice, online gaming, right? When you pay online through your browser for an item shopping cart, which port is your browser likely using for transport communication? 80. Now, if it is online and it has to do with
Shopping.
when you pay online
Payment.
browser for a time in internet, which port is your browser likely using to transport information? Shopping cart, most likely SSH, right? HTTPS. So, but for shopping systems, more likely we're going to have SSL implemented, right? So it's going to be this. If it's regular websites, static pages, and whatever, we can afford to do 80, right? So you can check up the answer later to see whether it is 443 or 80, but most likely it's going to be 443 because for a shopping system, you want, because you are paying, right? So if you are paying, then there has to be a green padlock. So it's going to be secured connection, then it's going to be what? 443.
443.
Right? Which device enables communication outside a LAN? So the router is the guy that can help us connect two LANs together or a LAN to another network. Right? You have been asked to create a VLAN inside the company LAN. Which device will you configure? It's a switch. Right? So it's a switch that you can do VLAN configuration on. Not a wireless, not a hub, not a router. So you do VLAN configuration in switch. That's why in Cisco networking, Cisco 1 is CCNA 1, that is introduction to networking. CCNA 2 is routing and switching, wireless essentials. So that's in CCNA 2, you learn all of these switching stuffs. Then in CCNA 3, you learn enterprise networking. It's called ENSA, enterprise networking, security, and automation. So which of the following devices match each of the following devices with our definitions? So wireless access points. Right? So this is it here. It's going to extend. Router is going to allow networks to connect to each other. Switch, forward packets, right? Broadcast, forward packets. Modem, just like a junction box. Firewall, protection. Yes, protection.
Prevent, right? Yeah.
Hub.
Is it B?
Switch will be B.
Yeah.
Then hub will be E. It's
E.
hub that broadcasts. So we says a switch is intelligent in forwarding packets, whereas a hub is not intelligent in forwarding packets. Right?
Mm-hmm.
Then patch panel as a junction box point for network cabling. Right? So that's the correct thing for that. Okay, I think that will be all. You could answer the rest of the questions, or we'll do recap review. Now, you see, you're able to have IMAP, right? 1110, FTP 21, HTTP 443, HTTP 80, HTTPS 443, SMTP 25, DNS 53, SSH 22, POP 143. So this is 110, 143, right?
HTTP is what?
HTTP is 80. HTTPS is 443.
443.
Okay, you should know the ports and their application and their use. Okay, that'll be all for today's session.
So where do I check the answers?
You want to check answers?
I mean, when I finish,
Sure,
you know,
sure. Sure.